Reality resembles a texture elastic like a trampoline net. Turn this trampoline net into a pretzel and permit yourself to go in reverse in time. Have you at any point scrutinized what's genuinely out there in the universe? What awe-inspiring secrets might the universe be hiding from us? Well, you're in for a ride. We have a disclosure so monstrous it changes all that we thought we knew about the universe. Brace yourself as the famous American physicist Michio Kaku reveals a theory that is completely progressive, exposed by, in all honesty, the unbelievable James Webb Space Telescope, which may have demonstrated that time doesn't exist. Ready to plunge into a space-time question that will turn your reality upside down? The James Webb Space Telescope is basically the Hubble Space Telescope's greater, cooler kin. Launched on Christmas Day 2021, this telescope has taken up home in space, enlightening mysteries from the universe's haziest and most far-off corners. It resembles a definitive time machine, furnished with super-strong infrared instruments that make it ideal for peeping into the past. How, you ask? Well, its remarkable goal and responsiveness permit it to identify staggeringly old and weak objects that even Hubble couldn't. We're discussing far-off galaxies and celestial bodies from the early universe, those tricky substances that have been playing an amazing vast game of hide and seek with us. Basically, James Webb is helping us piece together the universe's fantastic, elegant jigsaw puzzle, each infrared picture in turn. Now, envision you're at an art exhibition walking around great pictures caught by the James Webb Space Telescope, also known as JWST. The imagery is stunning, with far-off galaxies sparkling across the grandiose material. Yet, among the space experts and cosmologists, you see shock and incredulity. There's a feeling of unrest, as though they're gazing at a Picasso in a room brimming with pragmatists. A common expression you hear is, "This is startling. So what's the quarrel about?" What's shaken the very underpinning of how they might interpret the universe? Albeit the authority papers are quiet about it, the main problem lies with a hypothesis they hold dear, the Big Bang Theory. This is the real trick that our universe started off in a huge blast around 14 billion years ago and has been expanding like a giant balloon since. This hypothesis has been the foundation of cosmological understanding for quite a long time, and now the new pictures from the JWST appear to challenge its validity, sending shock waves through the community. Why is everybody so astonished? Well, the galaxies caught by the JWST aren't acting as they ought to according to the Big Bang Theory. They're too small, too smooth, too old, and there are an excessive number of them. How about we try to work on it? Assuming that you envision the universe as an expanding inflatable, galaxies shouldn't look smaller as they drift away from us. After a specific point, they ought to start looking bigger because their light evidently left them when they were closer. It's a peculiar, yet fundamental curve in the expanding universe concept. Yet, the pictures from the JWST show galaxies that are about the same size as the ones near us. It's like you're expecting your far-off friends to show up as little spots not too far away, but rather they're right next to you, as plain as the nose on anyone's face. Strangely, they show galaxies appearing smaller than we'd expect, even those that shine brighter and pack more mass than our own Milky Way. These photos show galaxies that appear to be a few times less than the ones seen through the Hubble Space Telescope, HST, regardless of their more prominent glow and mass. Furthermore, these galaxies also have entirely higher redshifts, which in layman's terms means they're likely moving away from us at quicker speeds. You may think, well, that is odd. And you'd be correct, particularly if you're working under the assumption that we live in an ever-expanding universe. Some time back, in 2014, several researchers had already pointed out this irregularity. They dissected HST pictures and found that galaxies with redshifts up to 5 appear to match what you'd expect in a non-expanding ordinary space. It was guessed that the JWST would continue this pattern, and it has, at least for galaxies with redshifts as high as 12. In more straightforward words, the JWST pictures show universes that seem the same size as those near us, as though the universe isn't expanding and redshift is simply a component of distance. However, if we still stick to the theory of the universe's origin and its expanding universe concept, we're left with a rather baffling conclusion. These far-off galaxies should be tiny to offset the assumed optical illusion made by an expanding universe. It's a bit like envisioning a grain of sand with the brilliance of a spotlight. Take, for example, a universe named GHC2 that the JWST detected. It's far more brilliant than the Milky Way, but is determined to be only 300 light-years in diameter, compared to the Milky Way's 50,000 light-year diameter. Its brightness per unit area would be 600 times that of the most brilliant galaxy in our local universe. Not just that, its density and that of several other newly discovered galaxies would be many times higher than the galaxies we see around us today. Now, when you consider these small and smooth galaxies, the concept of an expanding universe and, by extension, the theory of the universe's origin begins to disintegrate. And that is why these discoveries are creating quite a ruckus among astronomers and cosmologists. Over the years, the Hubble Space Telescope pictures struggled. The photos suggested the presence of numerous galaxies, thick and strong, similar to powerful mice from old cartoons. These galaxies are a difficult riddle in themselves, and with the new James Webb Space Telescope, things have just gotten trickier to make sense of these exceptionally tiny galaxies. Scholars have advanced a thought. It's as if you're playing with a little toy vehicle, a mysterious one, which, notwithstanding being just a centimeter long, weighs as much as a genuine SUV. They propose that these miniature worlds crash into one another over billions of years, consolidating to form the regular galaxies we see today. It's like the toy vehicles colliding and evolving to make an appearance to be real SUVs. However, here is the twist. The JWST has taken a close look at these galaxies and found no signs of such infinite vehicle crashes. You would anticipate that these colliding worlds should give a few indications of harm, right? Perhaps look a bit crumpled or damaged, like a vehicle after a minor collision. But that is not what we see. Rather, the JWST reveals galaxies that are smooth, flawless spirals, very much like the ones we see nearby. There's an overwhelming absence of cosmic bumper scratches. In fact, one study, aptly named a shock, highlights that there are multiple times more of these spiral galaxies than the scholars had anticipated. This is similar to finding a busy highway with speeding vehicles but no accidents. This is a pretty huge catastrophe for the collision hypothesis. Without any indications of cosmic mergers, the idea that these tiny galaxies somehow ventured into their more massive counterparts self-destructs. If they didn't grow in size, it means they weren't small to begin with, and thus the optical illusion we'd anticipate from an expanding universe doesn't seem to be there. Without this illusion, the concept of growth loses ground, thus the developing anxiety among Big Bang devotees. The presence of these tiny and smooth galaxies suggests that the universe may not be expanding. And if it isn't, the theory of the universe's origin suffers a significant blow. There's another aspect to consider: the age of stars. The theory of the universe's origin suggests that everything appeared following the Big Bang. Anyway, if these galaxies existed before that, then it would mean the Big Bang didn't occur. This could be a game changer for how we might interpret the universe's beginnings. Consider the James Webb Space Telescope as a time machine. In the words of Kaku, it is ready to peer billions of years back into the universe, catching pictures that shed light on the universe's origins. This mind-blowing gadget isn't snapping photographs in our natural visual range. Rather, it's focused on the infrared, uncovering shades of galaxies so far off we would never notice them with our unaided eye. Now, here's the intriguing part. These tones aren't just gorgeous. They're telling the age of the stars in these galaxies. Young, searing stars burst with striking blue, while their older, cooler partners, like our sun, glow in tints of yellow and red. By analyzing these tones, cosmologists can gauge the age of the star populations in these far-off galaxies. According to the theory of the universe's origin, the galaxies farthest away in the JWST pictures represent a cosmic snapshot from around 400 to 500 million years after the universe's birth. Anyway, some of these galaxies appear to house stars that are north of 1 billion years old. Now, if you've been following the theory of the Big Bang, you know that is a large issue because nothing ought to be older than the Big Bang itself. Another assumption, if the theory of how things came to be is right, is that as we look farther into space, meaning looking further back in time, we ought to see increasingly few galaxies until we arrive at where there are none. An enormous dark age, if you will. Anyway, it seems to be a different story. The galaxies as gigantic as the Milky Way were already quite common. Indeed, even a couple of 100 million years later, the alleged Big Bang. The new pictures demonstrate that there are something like 100,000 times more galaxies than anticipated at high redshifts, more than 10. So the question is, how could so many enormous galaxies form in such a brief time? The answer, they most likely couldn't. At any rate, not under the constraints of the Big Bang hypothesis. And that is why these discoveries are challenging the foundations of how we might interpret the universe. On top of that, there's a deeper philosophical quandary: the concept of time itself. Present-day material science works on the supposition that time exists, a basic concept profoundly imbued in how we might interpret the universe, interwoven with Einstein's theories of relativity and countless scientific principles. But what if time, as we understand it, doesn't actually exist? This hypothesis, although revolutionary, isn't totally new. Some theoretical physicists have been speculating that time may not be a principal part of reality, suggesting that our impression of time could be an emerging property or even an illusion. With regards to the universe's beginnings, this could mean that our interpretation of events transpiring in a sequence, with the Big Bang as the starting point, may be fundamentally flawed. If time, in the way we see it, does not exist, then the concept of a beginning like the Big Bang becomes meaningless. This could fundamentally modify how we might interpret the universe, requiring another framework that doesn't depend on time as an essential part. Rather, the universe may be better understood from a perspective that views spacetime as a whole, without a sequential beginning or end. This worldview shift might actually address some of the confounding observations made by the JWST, for example, the presence of mature systems in what we thought was the early universe. If time isn't a central property, then these galaxies could be older than the Big Bang without contradicting the laws of physics. Basically, without the limitation of time, the universe probably won't have a solitary start at all, suggesting a more complex and interlaced cosmic tapestry. In this new model, the universe could exist in a state where past, present, and future are not linear but coincide in a way beyond our current comprehension. This would have significant implications for cosmology, as well as for how we might interpret existence itself, possibly leading to notable discoveries about the nature of reality. The discussion between the Big Bang and steady-state theories addresses two fundamentally distinct views on the universe's nature. The Big Bang hypothesis posits a universe with a definitive start and a history of continual expansion. Conversely, the steady-state hypothesis suggests that the universe has no beginning or end, with a consistent average density and ongoing matter creation to fill in the gaps left by expansion. To summarize, the James Webb Space Telescope isn't simply offering another lens through which we can observe the universe. It's also presenting data that challenges our long-held assumptions about the universe's history. These observations could indicate that the theory of how things came to be, as it currently stands, isn't entirely accurate. Instead, the universe may be eternal without a specific beginning or end. This doesn't necessarily imply that all our understanding is wrong, but it suggests that there are deeper, more complex mechanisms at play which we have yet to fully grasp. It's an intriguing time for astronomy and cosmology, as we stand on the brink of potentially monumental revelations that could reshape how we might interpret the universe. Reality intertwined like a texture, an elastic sheet or a trampoline net. Imagine turning this net into a pretzel and allowing yourself to traverse back through time. These dynamic ideas set the stage for a significant investigation into the mysteries of the universe. Michio Kaku, a renowned American physicist, has recently unveiled a discovery that challenges our fundamental understanding of the universe. The James Webb Space Telescope, JWST, launched on Christmas Day 2021, has become an unmatched instrument for probing the depths of space. Unlike its predecessor, the Hubble Space Telescope, JWST's advanced infrared instruments can detect ancient and faint objects with remarkable clarity. It has revealed far-off galaxies and celestial bodies from the early universe, shedding light on their characteristics and behaviors. As astronomers analyze the JWST pictures, they find themselves confronted with surprising observations that defy the traditional Big Bang theory. According to this widely accepted hypothesis, the universe began with a massive explosion roughly 14 billion years ago, expanding ever since. However, the galaxies captured by JWST seem smaller, smoother, and older than expected. They challenge the idea that galaxies should appear larger as they move farther away due to the universe's expansion. This discrepancy raises critical questions about the nature of cosmic evolution and the validity of our current cosmological models. One captivating find is GHC2, a galaxy identified by the JWST that shines brighter than our Milky Way, yet spans only 300 light-years in diameter compared to the Milky Way's 50,000 light-year diameter. This galaxy's density and brightness per unit area are significantly higher than those observed in neighboring galaxies, presenting a puzzle for astronomers. The JWST images also reveal galaxies with higher redshifts, indicating faster apparent speeds away from us. These galaxies challenge our understanding of how redshift relates to astronomical distances in an expanding universe. Moreover, the JWST has uncovered an astonishing abundance of mature spiral galaxies in what was presumed to be the early universe. These galaxies appear as fully formed structures with stars that seem older than anticipated under the Big Bang timeline. If these galaxies existed before the supposed birth of the universe, it calls into question the very notion of a specific starting event like the Big Bang. This realization has ignited significant debate among cosmologists, pushing the boundaries of how we interpret time, space, and cosmic beginnings. Beyond the observational challenges to the Big Bang theory, the JWST findings also provoke philosophical inquiries into the nature of time itself. Modern physics operates on the assumption that time is a fundamental aspect intricately woven into Einstein's theories of relativity and our understanding of the universe. However, some physicists have speculated that time may be an emergent property or even an illusion, challenging the linear progression of events from a singular origin. The implications of these discoveries extend far beyond astrophysics. They suggest that our current models of the universe may be incomplete, necessitating a broader framework that accommodates nonlinear time and an eternal universe. This shift in perspective could redefine our understanding of existence itself, presenting a universe where past, present, and future coexist in a complex interplay. In summary, the James Webb Space Telescope is not only capturing breathtaking images of distant galaxies, but is also rewriting our cosmic narrative by questioning the foundations of the Big Bang theory and our concepts of time. The JWST invites us to reconsider the origins and evolution of the universe, marking a critical moment in cosmology that promises profound insights capable of reshaping our understanding of the universe and our place within it.